Now I am explaining our workflow. First is user input. The process begins with user inputs such as image, number of dots, grid size, symmetry type, and style choice. These parameters define how the column design will be generated or analyzed. Next step is column image conversion. The input image goes through pre-processing, where it is converted into binary form or skeleton form using OpenCV. And this step also helps simplify the pattern for analysis. Next step our is ML model for pattern analysis. With PyTorch, the ML model analyzes patterns, extract the number of dots, and validate the structure. It can also help to recreate and generate new column design automatically. From the extract the number of dots, we will go for the chatbot integration. A chatbot powered by NLP provides an explanation of the mathematical structure and cultural significance and background of that column. This adds an educational interactive layer for user. From the number of dots, we will again generate a new design. For that, we will go for the next stage, which is mathematical modeling. Using NumPy and SciPy, we apply concept of geometry, symmetry, and graph representation to model the column. The grid and dots are represented mathematically for precise structure. Our next step is algorithmic generation. From the previous stage, the algorithm based on Bezier curves, Eulerian path checks, recursive patterns are applied. This ensures smooth, accurate, and repeatable column design. Our next step is rendering and visualization. The validated design is rendered using Matplotlib, TrueSVG, and Manim animation. This produces smooth and scalable outputs like PNG, SVG, PDF, or even animation. Then the final output. The end result is a clean, scalable column design available in multiple formats, PNG, SVG, PDF, animation that can be used for education, cultural preservation, and creative application. The other side of our system is when the user input is number of dots or grid size or style choice. Then the next step will be mathematical modeling, which I already discussed. Using NumPy and SciPy, we apply concept of geometry, symmetry, and graph representation to model the column. Then we'll go for the algorithmic generation. Then the next step is rendering and visualization using Matplotlib, Turtle, animation with Mani. Then our final output is getting using PNG, SVG, PDF animation format.